Yeah, so I think our department is a really great place for a number of reasons. We have a large department, something like 25 tenure-line professors, as well as many research professors and postdocs and graduate students. And this lets the department support an amazingly broad research portfolio. We're doing exciting, cutting-edge work on cosmic surveys, on galaxies and active galactic nuclei, on cosmology, on star formation, on exoplanets, on high-energy astrophysics and particle astrophysics, as well as instrumentation and astrostatistics. There's all this stuff going on in the department, and that's only possible because of the fact we have one of the largest departments in the nation. And we're regularly making exciting discoveries, including, I believe, genuine breakthroughs in all of those areas. And it's rare to have a department that can do all those things, and we're fortunate to have such a department. Yeah, so I study the growth of supermassive black holes over cosmic time. I've been fascinated by black holes ever since I was a kid. I think many kids are. I get emails from kids who are interested in black holes all the time. And I feel kind of incredibly fortunate to be able to follow one of my childhood passions for my job. And so I use X-ray surveys to study supermassive black holes. I study their demographics, kind of like taking a census of how common black holes were over the history of the universe. I also study the physical processes that go on close to black holes, how the X-ray emission is made, how obscuring material is often present in the central parts of active galaxies, how active galaxies vary over time. And then I'm also interested in what I call black hole ecology. That is how black holes and galaxies have interacted with each other. We now know that black holes and galaxies are pretty fundamentally linked, and with the cosmic survey observations that we're doing, we actually are now teasing out how black holes and galaxies have interacted over most of the history of the universe. So for me, I've been very grateful to be in this department. One of the best advantages has been having access to the wonderful data from the Chandra X-ray Observatory, which is one of the world's leading X-ray satellites, as well as other X-ray missions. Penn State has been heavily involved in the Chandra X-ray Observatory for literally decades now. It was the principal investigator institution for Chandra's main CCD camera, and I've been fortunate to be able to exploit the data from Chandra since its launch in 1999. Also, I'd say equally important has been being able to work with many wonderful students who I've been able to develop while making discoveries with the data from Chandra and other observatories. So those have been some of the highlights for me personally in the department. So my lab, I believe, is one of the world's leading groups on X-ray and multi-wavelength surveys. We have a huge trove of truly wonderful X-ray surveys data that we've accumulated, and these data can be used to make exciting discoveries in many different directions. You can take these data and combine them to learn about growing supermassive black holes, or you can use them to learn about clusters and groups of galaxies, or about transient sources, or even about galactic stars. And so that's, I think, one big reason why the group is really great. Most recently, for example, we've completed a very large survey with the XMM Newton satellite, a 5 million second program, where we've surveyed many of the deep drilling fields that the Rubin Observatory is going to observe soon. And so as soon as Rubin switches on, we're already raring to go on studies of growing supermassive black holes in those fields.